So we're going to now look back at dashboard design explicitly. So we looked at kind of generally very broad data visualization and some key principles about that, and kind of focus areas that you can look at with data visualization. So visualizing things over time, visualizing things in the relationship to other things, and visualizing things in space. We're now going to look at, okay, once you kind of know generally what kind of information you need to display, what are some pitfalls? What do you need to watch out for? So these next handful of things are both useful formatively and summatively, meaning they're things to be thinking about as you're kind of creating your concept around visualizing the data, and they're useful for once you've kind of drawn some sketches to kind of take a step back and use this as a lens through which to critique that work for yourself. And specifically, we're going to look at dashboard design from the perspective of this guy, Stephen Few. Few is another kind of bigwig inside the data visualization space, but he's specifically really good at dashboard visualization. So what do we mean by dashboard visualization? The idea of dashboard visualization is how can you at a glance get a sense of where things are at right now? Like a dashboard on your car. You can at a glance see how fast the car is going, what the RPMs are, etc. And so how can you at a glance get a sense of how things are going? Now, what we're going to do now, this is going to be a little bit drinking from a fire hose. Feel free to pause and reflect and hit play and that kind of thing as we move forward, because it's a lot of stuff we're about to hit. We're basically going to summarize one of his big books, Dashboard Confusion, or no, I forget the title of the book. Sorry, I'm in my basement. I don't have my bookshelf in front of me. We're going to be looking at one of his kind of seminal books and condensing the entire book down into however long this lecture takes. And that book kind of goes over what he calls his 13 common mistakes in data dashboard design. So really quick, I'll hit all of them really quickly at a high level. One is exceeding the boundaries of you can read. So these big 13 issues, we'll look at some examples that he provides, and we'll also look at some kind of extending those examples. So the first of the common mistakes is exceeding the boundaries of a single screen. You know, if you were in a car and you had to look at to figure out how fast you're going, you had to look at your dashboard and then another screen, another screen, another screen. That gets totally overwhelming. You want to be able to very quickly, at a glance, see everything that's happening. So you can see here, this is daily sales dashboard in real time, everything all at once. Now, there's a lot of cheesy kind of elements here, like the literal dials, like the year-to-date sales and October units and return rate and all that kind of stuff being literal, like speedometer type things. Those are a little cheeseball. But you can see at least here, all the data that you would need to possibly understand is all available in one display. Another is supplying inadequate context for the data. So like this component of that display by itself doesn't provide a lot of context. So for instance, year-to-date units at 7,822. Is that good? Are we on track? Is that what we want to be? Are we under? Are we over? All that kind of thing. So here's a redesign of that. Like what if instead of this is a different type of data display, but this provides more context. So instead of just showing like year-to-date units, what if this one is how long a call length should be for a customer service call. But you can see here, it just simply annotates, hey, there's where we're at, the average one right now. Our company's average is down here, and the industry best practice is up here. And so that gives you a sense of where you're at inside of the data. So it provides context. It provides boundaries, railings, that sort of thing. Think about your health displays. Is consuming a certain number of calories in a given day, that doesn't really tell you that much. You need to have the context of those calories. Is that enough to maintain my current weight? Is that, if I'm trying to lose weight, is that a safe amount lower than maintenance that I'm hitting? Is, if I'm trying to gain weight but gain muscle, is the macronutrients breakdown of those calories in line with what I'm trying to do? And just providing context. Don't rely on the user to keep track of, oh, I remember I did the math and I'm 1,800 calories what I'm supposed to be eating or whatever. That's too much. Instead, display both where they're at and the context. It kind of shows them where they're at and the relevant rails around where they're at. Another is displaying excess detail or precision. So it's just showing, you want to avoid showing too much detail. knowing exactly down to the individual calorie of how much I've consumed in my hypothetical calorie tracking app is probably too much detail. I probably don't need to know that I've consumed 1,801 calories. Honestly, probably consuming 1,800 is probably too specific. Just be saying like, you're on track, you're over, you're under. That's probably good enough to give me a sense of where I'm at, especially considering when you look at, for instance, our calorie example, you look at like research into how those calories are calculated, and there's a huge range of possibilities. One bag of chips might say a certain calorie number on the bag, but there's huge tolerances around whether or not it's exactly that number of calories. So even the precision of the calorie is kind of a false sense of precision because it's probably a huge range of what's potentially being consumed. So in this display, you can see there's a lot of precision around dates. Do I really need to know exactly what time down to the millisecond in the top rectangle, down to the millisecond how long this thing lasted, or down the bottom you can see there's numbers where they're all the way out past the 1,000 unit after the decimal point of precision. It's probably way more precision than you actually need. So that's one of the common mistakes. Another common mistake is choosing a deficient measure. So this is actually one of my favorite examples that in redesigning a data display. So here is revenue of actual versus budget for a company. And you can see that the kind of the brownish line is budget and the greenish line is actual. This is not useful. It's noise. If I'm trying to just simply figure out, is this department, is its revenue on track where it's supposed to be or not, this is actually really complicated for me to figure out because I got to like look at where actual is versus budget. And so you can see sometimes I'm over my budget, sometimes I'm under my budget. It's a noisy display and it's not very helpful. Instead, the question I'm asking this data, this is an important thing to remember, is what's the user actually asking when you're displaying the data? The thing that they're asking is not what was the actual budget on week 18. The thing that they're asking is, was I over or under what I had budgeted? And so this is actually a better display of that. So budget is a stable line, even though in real life budget may fluctuate in given weeks. Budgeted number is a stable line, and then the actual amount is a percentage variance off of the budgeted amount. And this is actually way more useful. It shows me that, for instance, here in weeks 5 through 10, we had a really bad revenue estimate. We were way off on our budget. And in week 17 or 18, same thing. In our current state, we're also off. But we had a really good sprint there in weeks kind of 2 through 6 and weeks 11 through 16. And then you start asking the question like, okay, well, who's the manager during those weeks? Was it somebody different than when we were way off? Those kinds of questions can then be kind of launched out of this proper use of the correct measure that we care about. So again, in this example, the measure isn't the exact dollar amount. The measure is how much variance was there from budget to actual. This might be the same thing for your users. If back to our hypothetical calorie tracking app, which is not necessarily what I want you to build, just a good example. Knowing the exact amount of calories that were consumed in a given day is probably not that important as what was the variance around what we wanted to consume, what our goal was. Next is choosing inappropriate display media. So showing things just wrong. And to be completely honest, 3D pie charts like this are 100% always wrong. They're always the bad idea. It's very difficult to compare data into these little teeny slivers. And so thinking about what's the right way of showing this information is just as important as actually showing the information. Another common mistake is introducing meaningless variety in design. And so you can see here that along the top, the color represents the country, but then in the bottom left, color is like being used with the country on a pie chart type thing, and then it's all over the place. It's meaningless variety. It's not useful to see all this stuff. Instead, show the stuff that matters and be consistent as to what the different things mean. So different colors should be the same thing across all the displays. Different types of displays should show the same kind of information, etc. Using poorly designed display media is another common mistake. So here you can see this is a cool looking, although very difficult to read, 3D bar chart, just as a hint, 3D is probably always the wrong thing to do for these things. But this is poorly designed because you can see that, for instance, the green chart for telephone, I suppose that is, in the second quarter is so tall that you can't see the blue chart behind it. And it's even worse for the orange because the red is way on top of it. So, but by poorly choosing the right display media, it means that the information is getting obscured. Next common problem is encoding quantified data inaccurately. So what this means is, look, just be really careful that you're showing data and you're showing it properly. So here, it looks like this is all fine, revenue, cost, blah, 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 blah. The problem is, look at that lower left-hand corner. It's not going down to zero. It's going down to 500,000. And so you get the wrong sense of what these actual things are. So cost in January is not just this little teeny thing. Cost in January is like a little over $500,000. And so by not having the y-axis go all the way to zero, we're encoding our quantitative data inaccurately. Another common mistake is arranging the data poorly. This is just tons of information arranged in a way that seems completely arbitrary and doesn't reinforce anything. Mixed in the fact that it has this really gross skeuomorphic thing where you have like these digital numbers on the right-hand side and weird 3Ds and all that kind of stuff. But by arranging the data poorly, it makes it confusing. A lot of information being very, packing a display full of dense information is a good thing. It allows users to kind of wade in and understand things better. However, it's really overwhelming to them unless you highlight the important data. And so a common mistake is not highlighting the important data. What am I supposed to understand in all these line charts? What's supposed to be happening with those weird 3D bar chart or pie charts? Again, 3D is never the right answer. But you can see all those colors are so noisy that it just creates tons of noise and it makes it difficult for me to understand exactly what I'm supposed to be focusing on. And that kind of is related to the next common mistake, which is cluttering the display with useless information. So here's a graph of calories per 1,000 grams for different types of food. And what I'm going to do is kind of slowly peel it back and remove clutter. So very simply, we can remove the background and it starts to get more useful. Well, when you look at this, you start to realize, hey, why are French fries bright blue and potato chips green, etc.? Why don't we just make it so that everything is a common color and we highlight the data that's important? So let's say we're investigating bacon. Okay, that's a little bit better, but why do we have those drop shadows? That gets in the way. Now that I look at it, why do we even have the y-axis? Why don't I just put the data right on the bar charts? And suddenly we go from a display that's really noisy and full of clutter to something that's really crisp and clean and clear. Here's just another example, just simply downplaying axes so that the data itself can be elevated is part of removing useless decoration. Same idea. Here's a bunch of boxes and things like that. Just by removing those boxes, it makes everything a lot easier to read. Big old rules get in the way of the scatter plot by just simply setting those things down a little bit. The data itself becomes elevated. Sometimes people think that cluttering the display with useless information like this just creates a ton of noise. But really, by adding a layer of interactivity, you can make this giant noisy thing actually really useful and insightful. So for instance, here's a graph of life expectancy for every single country in the world. And at first, it seems totally overwhelming. However, this interaction allows you to filter. So here we have every single country in sub-Saharan Africa. And that tells an interesting story. Look how much worse life expectancy is for this cohort than the rest of the world. The other, however, thing that's kind of surprising is that if you look at today over in the far right-hand corner and compare it to 1980, well, to most of the countries that are highlighted here would have been in the middle of the pack in 1980. So while sub-Saharan Africa is certainly struggling and has a long way to go and we should be investing resources there to make it better, it does tell a story where it says, hey, as bad as we think it is, it's still improving significantly, and that's good. Another thing that this interactivity allows you to do is roll over specific lines and find out who it is. I'm going to give you, I don't know, 15 seconds, 5 seconds, 3 seconds, whatever, to try to guess what that big dip is in sub-Saharan Africa. If you know much about the Rwandan genocide, you can probably guess what that was. Right there, that was Rwanda in the early to mid-90s. All right, another common mistake of Fuse is misusing or overusing color. We're coming back to this display here. You can see that these colors mean something different in every single one of those graphs. So that pink color in the line graph means something totally pink, and then the next line graph, then the next line graph, then the next line graph. If we're going to use color is vitally important. If we're going to use color, we should be consistent about what each color means. So pink should always mean this, green should always mean that, etc., etc., etc. Next in his stack of common mistakes is designing an unattractive visual display. This tool might be incredibly useful, but if you just kind of slam it with a bunch of ugly stuff and just overwhelming amounts of noise, it just gets in the way of what you need to do. So those are Fuse 13 different principles. I think they're all useful. I think they're worth thinking about. I think they provide a starting point for your sketches, and they provide a filter for going back and rethinking everything once you've kind of done some initial sketches. I think it's important to kind of take note of these, take a screenshot of these, write these down, whatever, and use them as a filter as you move forward. All right, let's talk about next steps this week. So next, what you're going to do is contribute to the discussion board, where you're going to look at the apps that you used over the previous part of the semester, and you're going to identify which have good data displays, and you're going to critique them using the different terms and principles that we just talked about and share with the class. And then you're going to take one of the aspects of health, one of the 5 axes that we talked about, and you're going to really narrow in on that concept and build on that concept that you had. And over the next couple of days, I want you to take your concept and do some sketches as to how could you visually communicate progress to the user in the form of data displays along one of those different axes. So if you're worried about physical health, the calorie example is a perfect example of that. If you're worried about kind of meaning and purpose type things, it might be tracking the amount of, the amount of times that someone has engaged in a meditative practice. Or if you're talking about relational health, showing a graph of who they're connecting with relationally and what the relational health of all their family members are, or their friends, or whatever, et cetera, et cetera, et cetera. You're going to be doing kind of sketches of that over the next couple of days. And then on Thursday, we're going to try a synchronous deal, which I have yet to do before, but we'll find out how it goes. We'll start off as one big Google Hangout, and I'm going to create little sub-Google Hangouts based on the different axes, the 5 different axes that you have, where you kind of do online critique. So come on Thursday ready to be able to show the work that you've done, either presenting it directly in Illustrator or Photoshop or XD or whatever that you're working in, or just kind of showing pencil sketches and that sort of thing. Doesn't really matter to me, but this is an opportunity to get feedback from your classmates. And while you guys are doing that, I'll jump between the Google Hangouts to kind of check in and see how things are going. So that's our next steps. I hope you're all doing well, and I'll see you in person on Thursday.